Example, letter A, product of binomial. Now let's recall how to use FOIL method. So for example, you're given two binomials and multiplying A plus B to the quantity of A plus C. Let's identify the first terms, followed by the outer terms, that's A and C. We also have inner terms, that's B and A, pointed on the screen right now. Then we also have here the last terms, that's B and C. So that is your FOIL. First, outer, inner, and last. So how do we get the answer or the product of this one? The result will be the product of the first terms, that's A multiplied to A, giving you A squared. Okay? Then add it to the product of your outer terms. That is your A multiplied to C, therefore you have AC. Now, we have here the third term, that's plus AB. Where did we get AB? That is the result of your inner terms. B times A, and having it alphabetically, that is AB. Plus, the last term is coming from the last terms of our two binomials, which is B and C. So this is now our answer, A squared plus AC plus AB plus BC. Now, there's another pattern for this. Now, let's have an example using the FOIL method. For example, we have here the quantity of x plus 2 multiplied to the quantity of x plus 5. So we are going to get the first terms, the product of the first terms, that's x multiplied to x for our f. Followed by our outer terms, that's x and 5. Then we also have our inner terms, that's 2 and x. Then our last terms are 2 and 5. So following the FOIL method. To get the answer, we are going to multiply or get the product of each terms. So for the first terms, the outer terms, the inner terms, and the last terms. So look at my laser pointer. For the first one, that is x multiplied to x, will give you x squared. Add it to the next product, that is the outer terms. That's x and 5. So that will give you, yes, correct, that's 5x. Then for the inner terms, that's 2 and x. So the answer is good, that's 2x. And finally, our last terms are 2 and 5. So what's the product of 2 and 5? Nice, that's 10. So the final answer here is, actually the answer using the FOIL method is, let's see, and let's compare. So you have here x squared plus 5x plus 2x plus 10. Now observe that at the center, you still have two terms having similar terms. You have there two terms with a variable x. So what do you need to do here is, okay, you need to add similar terms. So the result now is x squared plus 7x plus 10. Since you added 5x and 2x right here, giving you 7x for the middle term. So the final answer is a trinomial, which is x squared plus 7x plus 10. That is correct. So that's how you use FOIL method. Just a review. Now this time, how do we use patterns to get the product of binomials? Say for example, the same set, we have here quantity of a plus b multiplied to the quantity of a plus c. So we can follow this pattern. Square the first term a, so we have a squared. Next, we have here add it to the product of A and the sum of B and C. So add first B and C, then multiply it to letter A. Then the last term is the product of B and C. So that will be for the pattern. So how do we use that? For example, x plus 2 multiplied to x plus 5, same example for the FOIL method. So here, I'll use my laser pointer. Observe. First terms are x, so that will give you x squared, following the pattern as shown above. Here, we have b plus c, so our b here is 2, our c is 5. So get the sum, 2 plus 5, 7. Multiply it with a. Our a in this example is x, so that was 7, right? 7 times x will give you 7x. And our last term is the product of b and c. So we have b is 2, and C as 5. So the product of 2 and 5 is 10. So that will give you 10. So the answer is x squared plus 7x plus 10, having the same result when we use the FOIL method. So that's it for the first pattern. Correct. Now, how about for the square of a binomial? Your binomial in this example is a plus b, and you're getting the square of that. So to get that, we can use this pattern. Square the first term and add it to twice the product of a and b. Then the last term will now be the square of your given binomial. Square of the last term of your given binomial. So that would be the pattern. A squared plus twice the product of a and b plus the square of b. Example. We have here x plus 2, or quantity of x plus 2 squared. So we will follow the pattern. It will give us a squared, which is x squared, since our a here is x and our b is 2. So x squared plus, how did we get 4x? We have here multiply a and b, then double it. So you have x times 2, that will give you 2x, then double it, it will give you 4x. Plus, the last term here is the square of your b. So our b is 2, so the square of 2 is 4, thus giving us this trinomial, x squared plus 4x plus 4. That's it. Very good. The next is cube of a binomial. This would be the next on our list for the special products. How do we get this? Now, let's try to recall the pattern. So we can get the value of this one, the cube of our a plus b, by cubing the first term, that's a cubed, plus 3 times the square of the first term multiplied to the second term. So that's 3a squared times b, followed by 3, and then copy a, then square the second term b. Then our last term for this polynomial is, the result is more than 3. So it's not a trinomial unlike the previous example. So here is a polynomial with 4 terms. So our final term, or the last term, is the cube of the second term. So we have b cubed. So this is now the pattern for cubing a binomial. So the next part and the last pattern that we are going to tackle and review is sum and difference of two squares. So let's have here a plus b, the quantity of a plus b, multiplied to the quantity of a minus b. So how do we get the product? It's a special product. The pattern is square the first term, like this, a squared, minus square the second term. That's it. You will get the square of b, so the answer is minus b squared. Like that. So that will be the pattern for this special product. Let's have an example. Let's say you're given the quantity of x plus 3 and you're going to multiply that to the quantity of x minus 3. Now, it follows the same pattern as what we have earlier. Now, how do we get the answer for this? We are going to square the first term, giving us x squared, like this, minus the square of the second term, which is 3. So that will give us 9. So the answer here is x squared minus 9. That's correct. Very good. I hope we have now reviewed everything for our special products. So what's new for us? Now on the screen right now, you can see here 6 questions. Your task is to get the product of the following polynomials. I've asked you earlier to prepare your pen and paper. So this time, I want you to get that and try to answer and get the product of the polynomials shown on the screen. Now, to help you out, I prepared here the table that summarizes our special products and the result using the patterns to get the result. So do not forget to pause this video and take your time. You have there 6 items. Okay? Are we clear? Again, pause the video and you can play it once you are ready to confirm your answers. Now, let's do this. You can pause the video now. Okay, are you done? All right. let's have guide questions first. I know you have already the answers on your notebook or on your paper. So based on the answers, before revealing the complete answer or the solutions, now, what have you observed with each resulting product? Did it have the same number of terms? And which of the following products have the same number of terms? Now let's answer that by showing to everyone the solution in this table form. So this is the result showing this table with 3 columns, wherein our first column shows the given, the method for the second, the method and how to get the answer, and finally on our last column, it shows the result. Now, what do you observe? Do all the results show the same number of terms? Observe that there are answers inside the red box. What are the similarities? Good. So these terms, or I mean these answers inside the red box shows 3 terms, right? The result is a trinomial. While on number 4, we have here a binomial and we have a multinomial for number 6. Now, which of the products have the same number of terms? That will be numbers 1, 2, 3, and number 5. Number 4 is a binomial and number 6 is a multinomial. I hope that's clear. Now this time, what we need to do is to focus on the results inside the red box. Now let's focus our attention for that 4 results. Now observe that this one shows the following components. Look at the first part, the first term of the trinomials. So what do you observe? It follows ax squared, wherein your first term is considered as a quadratic term. The highest degree is 2 of your variable. So here, the highest degree for the first term of the first answer is y squared. That's y with the variable y with the degree of 2. Same with the second, third, and fourth. They differ with the variable. Second is r, third variable is x, and here for our last example, the variable is z. Now, what do you mean by a? A here represents the numerical coefficient of your x squared. So here, our y squared has the numerical coefficient of 1, so that will be a is equal to 1. Same here for the second one, pointed by my laser arrow, my laser pointer. So I have here 1 for a. Then here, the numerical coefficient of x squared is 2, therefore your a is equal to 2. And for the last example, our a here is 1. Okay, that's clear. Now, I hope that's clear. So this time, let's focus on the second set. That means we are going to look at the second term or each of the second term of our examples. Now, it follows this format. It's bx, where your b is the coefficient of your x. That's your second term and it's a linear term since the degree of this will be 1. Okay, so here our bx is 7y, the value of b is 7 with the variable y. In the second example, it's minus r. So our b is, take note, it's negative 1 since it has here negative. So again, the value of our b is negative 1 with the variable r. The third example here is negative 5x. So our b is negative 5 with the variable x. And our final example here is 8z. Our b is correct, that's 8, and with the variable z. So again, this is our second term, and it's a linear term, meaning the highest degree is 1. Okay, now, let's move on with our third set. That is looking at the last terms. So here, we are going to have c. What does it mean when we have c? Now, it's our third term, and c represents the constant number or the constant of our expression. So here, in this expression, look at this. This will be our value for c. That's negative 12. Here, it's still the same, negative 12. And in the third example, our constant is positive 2. And in the final example, our letter c or constant is positive 16. So these are the 3 properties, the properties that we have to make it a quadratic equation. Take note that it has the first term, which is a quadratic term, the middle term or the second term as a linear term, And we have here the last term of our trinomial, which is our constant represented by letter C. Okay. Speaking of quadratic equation, now what do